Hello, welcome back. Let us start numericals 16 to 21 of exercise 8C. 16th, two resistors A and B of values 4 ohm and 6 ohm are connected in parallel and the combination is connected across a 6-volt battery of negligible resistance. So here we have one resistor 4 ohm, second resistor of value 6 ohm, and that is connected to 6-volt battery of negligible resistance. So we can neglect the internal resistance of the battery. 6 volt is the potential difference or EMF. Calculate the power supplied by the battery. So let us first find out RP, that is R1 into R2 upon R1 plus R2, 24 upon 10, 2.4 ohm. Once we know the resistance, we can use the formula P is equal to V square upon R to find out the total power. Voltage of the battery is 6, so 6 into 6 upon 2.4, that is 6 into 6 into 10 upon 24, 4, 2, 3, that is 30 divided by 2, 15 watt. So 15 watt is the total power supplied by the battery. And then we want to find out power dissipated in each resistor. So once again we can use the same formula for bulb 1 or for resistor 1. P1 is equal to V square upon R1. V is same as the battery voltage, 6 into 6 upon R1 is, let's say, 4 ohm. So this is 9 watt, and P2 is V square upon R2, 6 into 6 upon 6, 6 watt. So then you can see that 6 plus 9 is equal to 15 watt, that is the total power supplied by the battery. 17th, a battery of EMF 15 volt and internal resistance 2 ohm is connected to two resistors 4 and 6 ohm in series. 4 ohm, 6 ohm, they are connected in series, and that combination is connected to 15-volt battery. So EMF is 15 volt and internal resistance is 2 ohm. Find the electrical energy spent per minute in 6 ohm resistor. So let us first find out what is the current flowing through 6 ohm resistor. And to find the current, we have to use the formula E is equal to I into R plus small r. What is capital R? That is addition of 4 and 6, 10 ohm. So now EMF is 15 is equal to current we want to find out. R is 10 plus small r is 2. So 15 is equal to I into 12. Current is equal to 15 divided by 12, that is 5 upon 4, 1.25 ampere. Okay, 1.25 ampere is the current flowing through 6 ohm resistor. Now we can use the formula E is equal to I square RT to find out the energy spent in 6 ohm resistor per minute. Current is 1.25, or let me write 5 by 4. So I square is 5 by 4 into 5 by 4 into resistance value is 6 ohm and time is 1 minute or 60 seconds. 2, this is 3, this will be 30, 2 and 15. So this is 25 into 45 upon 2, and that is 562.5 joules. 18th, water in an electric kettle connected to 220 volt supply takes 5 minutes to reach to its boiling point. How long will it take if the supply voltage falls to 200 volts? Now we know that if the voltage drops, the electrical energy consumed or the power consumption also decreases. One thing does not change is its resistance. Resistance value does not change. It remains constant for a given appliance, no matter to what voltage it is connected. So here the resistance of electric kettle is constant. Now think that initially when the kettle is suppose completely filled with water and the electrical energy is supplied by the kettle to the water such that it reaches to its boiling point. So let's say initial temperature is 30 degrees Celsius, final temperature of water is 100 degrees Celsius. There is certain quantity of water in the electric kettle. So it absorbs certain fixed quantity of heat energy to increase the temperature from 30 to 100 degree Celsius. Now, if I connect the kettle to 220 volt supply or to 200 volt supply, the energy absorbed by the water for this particular process does not change. Okay, so heat energy absorbed by water is also another constant here we can say. This is constant. So using these two constants now we can find out that how long will it take if the supply voltage falls to 200 volt. Let us see how. See energy is equal to heat energy absorbed by water is of course mc delta T. But this heat energy comes from where? From the electrical energy. And electrical energy formula is V square upon R. Okay, we will use this formula V square upon R into T. So E is equal to V square upon R into T, and this electrical energy gets converted into heat energy, and using that heat energy the temperature of water reaches up to boiling point. Now we know that energy is constant, so I can conclude that V1 square upon R1 into T1 is equal to V2 square upon R2 into T2. Here resistance of the kettle is constant, so we can cancel that. V1 is 220, so 220 into 220 into time is 5 minutes is equal to V2 is 200 into 200 into T2. So T2 is 220 into 220 into 5 upon 200 into 200, and this answer is you will get 6.05 minutes after doing some mathematics. 6.05 minutes. Next, an electric toaster draws current 8 ampere in the circuit per with source of voltage 220 volt. It is used for 2 hours. So how much current is drawn? 8 ampere. For how long? 2 hours. Find the cost of operating the toaster if the cost of electrical energy is 4.5 rupees per kilowatt hour. So toaster draws a current of 8 ampere. 8 ampere current is drawn. Voltage is 220 volt and it is operated for how long? 2 hours. So to find out the cost, first we need to find energy in kilowatt hour, and for that we have to use the formula E is equal to VIT. Voltage 220, current 8 ampere, time 2 hours, but this will be the answer in watt into hour. Okay, watt into hour. So this is 220 into 16 watt hour, and that is 220 into 16 upon 1000 kilowatt hour. This is the electrical energy consumed. So now we can find the cost as energy, which is energy into rupees. What is the total energy consumption? 220 into 16 upon 1000 into cost for 1 kilowatt hour is 4.5, or we can say 9 by 2. So on simplifying this we get the answer as 15.84 rupees. 15.84 rupees. 20th. An electric kettle is rated 2.5 kilowatt 250 volt Find the cost of running the kettle for 2 hours at 5.4 rupees per unit. Cost of running the kettle for 2 hours. Okay, so we have to find out energy first in kilowatt hour. That is power into time. Power is 2.5 kilowatt, or we can say 2.5 into 1000 watt into 2 hours. It's better to keep power in kilowatt only. So let me just keep it 2.5 into 2, that is 5 kilowatt hour. So now cost is equal to 5 kilowatt hour into 5.4 per unit, which is 25 into 27 rupees. Answer is 27 rupees. 21st. A geyser is rated 1500 watt 250 volt. This geyser is connected to 250 volt mains. Calculate the current drawn. So current is equal to P upon V, that is 1500 upon 250, 6 ampere. Current is 6 ampere. Energy consumed in 50 hours. Energy is equal to power into time. Power is 1500 watt into 50 hours. Convert watt into kilowatt, divide by 1000, 75 kilowatt hour. And the cost of energy consumed at 4.2 per kilowatt hour. So cost is equal to 75 into 4.2, that is 315 rupees is the cost.
Thank you for watching. Please check the link in the description below for more numerical videos. Please like, share and subscribe to my channel.